Hi, I'm Silviana Amethyst, and I'd like to talk with you today about a technique for solving limits that involve common roots of rational functions. So on the screen, we've got a limit written up. The limit as x approaches -3 of, now, a rational function. It's a rational function because it's a ratio of two things. In the top, x plus 3, and in the bottom, x squared plus 7x plus 12. The first thing I try when I approach limit problems is I'm going to just plug it in, because that's what I really want to do. For continuous functions, you can just plug in the value of interest for x and it just works. So I'm going to first try to plug it in. So if I plug it in, I'll be all like, well, let's go -3 plus 3 over -3 squared. Use those parens to try to keep that minus sign from accidentally escaping to the outside, plus 7 times -3 plus 12. That's equal to, we got a 0. 0 in the numerator isn't necessarily bad. If I also get a 0 in the denominator, it's also not bad. It's just a thing. That means I've got to do something else to figure out what it is. We're going to have 9 minus 21 plus 12 equals 0 over 0. Okay, fine. So this is what's called an indeterminate form. Indeterminate form means that I can't determine what it is in its current form. And so we've got to do something to transform the expression for the function so I can strip away that layer of mask to find out what's hiding behind it. So let's strip away that layer of mask. This problem, I've got a linear up top, and I've got a quadratic in the bottom. So that means that if I have 0 over 0, I've got a common root. And what I'm going to do is I'm going to try to cancel that common root by factoring. That is to say, I'm going to use the method of factor and cancel to solve this limit problem. What I'm going to do is I'm going to very carefully, step by step, write this down. So this limit is equal to the limit as x approaches -3. I'm going to be really careful to carry that limit symbol with me, because if I just start writing that that's equal to some algebraic thing without the limit, it's probably not true. So in the top, I've got x plus 3, and in the bottom, let's factor. So I see that we have a product of 12 and a sum of 9. So this factors as x plus 4 times x plus 3, because 4 times 3 is 12, and 4 plus 3 is 7. Groovy. So let's write down that this is equal to the limit as x approaches -3 of, well, I can cancel the x plus 3's. 1 over x plus 4. So now I did work. And anytime that I've done work and done a transform on a function like this, now I'm going to try to just plug it in. So I'm going to try plug it in again. So I'll try plugging it in. And is this equal to 1 over -3 plus 4 equals 1 over 1 equals 1. And because I plugged it in and I didn't get an indeterminate form, that means that I found what the value of the limit is. So in factor and cancel, our objective is to factor both the numerator and the denominator and cancel common roots. It's possible that there might be a common root multiple times. And in that case, you just do it multiple times. No problem. So thanks for watching, and good luck factoring and canceling.